All right, everyone. Welcome to another CocoaHeads event. CocoaHeads 100. Can you believe that? Oh, so it's crazy. How long have we been around for? Leo, when was the first event? 11 years. That's been a while. And then back then, we barely even had iOS, right? At that point, it was just a Mac developer community. Yeah. Oh, well, with some jailbreak, perhaps. It's super fun to be here in this amazing studio. I'm so glad that Sveriges Radio could be hosting us here. Is anybody here in the audience new to CocoaHeads? A couple ones. Well, then, this slide is for you. So we're a monthly meetup, but we also have a thriving Slack community. So we're over 350 members actively discussing all things Apple dev related on Slack. We live stream all our talks. So we have a live stream going on right now, and we will record all of the presentations tonight. And they will be up on YouTube. You can also make sure to follow us on Twitter and on Facebook. We'll post some photos afterwards. All right, so us who are organizing CocoaHeads, it's me, I'm Alek. We have Edward here in the audience. We also have our newest member of the organizational team, who is Martin Andonovski. He's going to be up on stage together with us later tonight as well. And we have Daniel Kenneth, our community photographer. I don't think he's here tonight, but we have some photos from the Sveriges Radio crew instead. I think that's going to be great. All right. Also, looking at diversity, like we try to encourage as much diversity as possible, and one of the ways we're doing that is to have guaranteed seats for women. So anytime there's an event which is full, women always get a preferred seat to skip the waiting line. And if you have any suggestions for how we can improve as a community, what events we should do, what speakers we should bring in, or what new places we should go to, please reach out to any of us. And spread the word. Use the Stockholm Tech hashtag if you use Twitter. Follow us on @CocoaHeads Stockholm, and make sure everybody knows how great of a community we have here. All right, so let's look at tonight's schedule. First, we're going to have a presentation by Narek, who's behind the camera right now, about building an MVVM framework, which is shared between iOS and Android using Kotlin Multiplatform, which is going to be super exciting, I think, using a software language coming from another platform as Android, and how you can use that on iOS. We're also going to have, we filled the lightning talk spot thanks to Tobias Löfstrand. Where are you here in the audience? Somewhere. There should be a Tobias here. Maybe he's running slightly late. I hope he finds his way here. After a short break, then we're going to do a small fireside chat with some old former organizers. We have Leo with us tonight, who's one of the founders of CocoaHeads Stockholm, and Nevyn, who's also going to do a presentation later, and has been a long-time community member. And speaking of Nevyn, he will finish off the evening with a talk on Metal, the graphics framework. So, and then after that, we're going to be able to stay here until 9 p.m. Am I right? That's great. So, with that said, I'd like to hand over to Ann from Sveriges Radio. Give it up for Ann. Should we do it? In order for them in the stream, I think it's best if we turn this on. You can use this, Alek.
Okay, I'll use this then. So my name is Ann, and I work here at the Swedish Radio as an HR strategist, focusing on employer branding and diversity. So I spend most of my days here thinking about how we can keep the employees that we have engaged and passionate about SR and tech and IT at the Swedish Radio. And of course also to how we can attract people like all of you here to come to the Swedish Radio and work for us. I will be very brief here, but I would just like to say a few things about the Swedish Radio. As you all know, we are very focused on sound and voice, as it's within our mission. And when I walk around and talking to the people who work here, especially at the IT and the tech departments, and asking them, so why do you work here? Why don't you go to Google or wherever they might want to go? And most of them say that it's because our public service values. And I think that's very worth mentioning because, as you all know, we have a very divided and polarized society with a lot of fake news and so on. And I think we do have a very important mission. And if you work as a journalist or as a developer or whatever, or an HR strategist, we all really have those values within us. It's very, very important for us who works here. We all work together to make the best radio ever. And I think we really succeed in that when it comes to all the things we should do as a public service company. And also they say that, and what else I say, that's a given, but what else? So they say, well, okay, it's good to work here because you really you do have a great work-life balance. It's not something we just say. We do have a great work balance here. It's okay to go home and pick up your kids or to stay home with sick kids, and you can work part-time. And I think that's also worth mentioning. And 2 weeks ago, we won the prize as Sweden's most equal company when it comes to gender diversity. An applause for that, please. Yes. But also, what they say is that we do have the muscles to really innovate things and to really, as a public service company, we always need to look behind the next door to see what's coming. Before even Alexa and Google Home was a part of Sweden, we were there to see what we have to be the first one there to say when Google tell us the latest news. It has to be the Swedish Radio's news and etc. And also, I think it's important to mention that we are, when it comes to certain techniques, I'm an HR, so I won't go into that. We are world leading, so people from all over the world, from BBC, we develop solutions, software and hardware that is unique and world leading. And I think that's pretty cool for a public service company. Narek, what else? No. So please don't hesitate to give us a head up on our career sites, and should be so welcome to be here. This is a very cool studio. Every Friday we send cool artists from here. Jimi Hendrix played here, and we have had so many different artists here. So this is really like an old, cool studio. So have a great evening. I will be around here. Have to work a bit now, so I will go to my office, but I'll see you in a bit.
Thank you very much, Ann. So now let's welcome up our first speaker for the evening, Narek.
Hello, can you hear me? Awesome. All right, let's see if we can get this started. Can't find my mouse here. Where'd it go? Oh, it's on that screen, isn't it? Let's see. Oh, okay, cool. Yeah, I'm not used to this. All right. Hello, my name is Narek Mailian. My position here at Sveriges Radio is as tech lead for the mobile app developers. Now, I've mostly worked as an iOS developer, so I'm one of few people. I feel it's fairly important to mention, given the nature of this talk. So I'm not like a crazed Android developer trying to lure you over to the evil side, no. In this talk about designing a shared MVVM framework using Kotlin Multiplatform, I'll speak a bit about the use cases we had while building a new MVVM framework for Sveriges Radio Play, and why we decided on Kotlin Multiplatform. I'll try to give a general view of how the app is structured, our use cases for a shared code base, and how Kotlin Multiplatform fits within it. And then also a shorter dive into what you can and can't do with Kotlin Multiplatform. Then I'll tell you about how we designed our framework, what we learned, and what you need to think about when designing your own. I'll also go through some general good and bad stuff we found while working with Kotlin Multiplatform. Now, I won't go far into how the app is structured or architectured. If you have any questions about that, just catch me afterwards, send me a mail, or just contact me in whatever manner you feel is appropriate, and I'll be more than happy to talk about that. Because transparency and openness is very important for us at Sveriges Radio, and that extends to us developers as well, as Ann said. So also, some of the code I'll show you today is a bit simplified, but general idea is the same. Now, I know that this is the 100th CocoaHeads meetup, so I don't mean to steal the spotlight here, but there was another big anniversary last month, actually. Does anyone know what it was? No? In March of 2009, the first version of our app, Sveriges Radio Play, was released for iPhone. And it has its own distinct look and feel nowadays. It even lived through the hamburger menu era and now has embraced the tab bar fully. So the more things change, the more they stay the same, right? When we started out, it was a simple podcast player, but nowadays you can listen to our radio channels, you can download pods for offline listening, you can listen to the latest news and more. Now, one of the biggest changes we've done, at least in regards to design, was a switch we did about 2 years ago to start using a component-based layout. So our designers started to work on this design system, as you can see part of here. For instance, we have this component right here. This is called the small episode card carousel. Now, keep that in your heads, because I'll be referring to this in a bit. So we try to have just one kind of component to represent one kind of content. So this component only represents a list of episodes. Now, this component can appear in many different places in the app, but with different content. So here we see popular episodes, episodes that are recommended from another episode, courtesy of our recommendation engine, and then episodes from programs you follow. Now, here at Sveriges Radio, we do a lot of A/B testing, and we're not in this for the money, so we don't need to maximize our ad revenue or clicks. But when we do A/B testing, we do it mostly to learn about how our users interact with the app, and that promoting certain types of content won't have a negative impact on other types of content. We also do some personalization, which requires us to be able to inject, remove, move around components, and this has had a major impact on how we structure our code as well. For a very long time, this is how we would define a screen, as you can see here, a bit simplified, but still we'd have like a screen class, and then we'd just populate it with view models that would just provide us with the state and updates and everything. So the data flow of the app looked somewhat like that. I'm sure many of your apps have had some similar architecture, probably with different names, but I guess this is a fairly common way of structuring your app. So we have like this entity API, which will give us episodes or programs. And then these are fed through the presentation layer. Before they do that, of course, they're converted into Swift structs, and then they're fed into the presentation layer. Presentation layer is basically the screen layer where where we decide in which order and which components you'll get based on your A/B test configuration or which user group you belong to. And then we have this view model class, which will turn a collection of episodes into a carousel with smart episodes cards that are then rendered on the screen by the view layer. But of course, the real world doesn't really look like this because we got another platform to think about, right? So we basically have to copy-paste all of the code that we have written. Now, if this has worked for 10 years, why do we... You need a good reason to change it, right? Well, first of all, obviously, like, we got a lot of duplicated logic in both of the clients, and we know from, school that the code duplication is a bad thing. And during the long time in which Play has existed, we've learned that no matter how closely we work together while designing features, you always end up with small differences, even with the best intentions. Maybe you fix a bug in a model's JSON deserialization, and then you skim through the code, and you see another, like the same problem with another model, and you fix it, and you forget to tell the people working on the other platform, and boom, you got like a diversion there. And these have a tendency to start adding up, and after a while, you start putting a lot of strain on, well, firstly how you develop your apps, but also on other, like the API, for instance, that depending on how it's built, of course, now needs to conform to 2 different model definitions. It's also not the best way of being agile when you have an app like ours, when you want to A/B test and personalize content, since everything has to be in the client. And it's also a barrier for other teams to contribute to. So one way of restructuring the app, I guess, could be something like this. You'd introduce a backend for front end in a cloud somewhere, and then you take the data from the entity API, run it through the presentation layer and the view model layer, depending on which groups you belong to, and then you deliver a view model representation that you can use to build your view form. So we'd get something like this maybe from the server. And here, the content would represent data that can be used to initialize or set up a single cell. Let's call this view data for the purpose of this presentation. Now, we found out that this isn't like, we needed some more data. For instance, we need the ID for the episode in order to do some post-processing client side, maybe remove an episode from a certain carousel if you already listened to it from the client itself. Then we needed some more data for tracking. We do tracking client side, maybe you don't, but that's how we do it. And then we also needed some more data for actions. So at this point, we're basically sending the whole episode object anyway and just hoping our users got a good data plan. And even if we went with this approach, we'd still need the mapping from episode to small episode card in the client. Now, in Play, among other things, we store your podcast listening history and your downloaded podcast for offline listening. Since an episode can be represented with different components, we can't really store these components, the content of the components locally. We need to store the episodes in core data, use mappers to convert it from episode to small episode card in the client. We also need to calculate the value of minutes left from the local database, as shown in this tag text right here, and we didn't want the server, to take care of this. So basically, this didn't really work out for us. So what we thought about was just to move this view model to the client instead. Let the client get the actual screen with the objects instead of view model or view data representation. So here, the content would instead refer to an episode. Then you do this mapping from episode to small card carousel on the client itself. The good thing with this approach is we'll solve some of the code duplication up until the presentation stage, but we still have to implement this mapping in the client, the episode to small episode card. We also need to have the same entity definitions in backend, iOS, and Android, and we have to synchronize our serialization and deserialization. So we said, hold up, what if we just share all these things between iOS, Android, and maybe even the backend, instead of implementing the exact same code separately on all platforms? Why did this sound so tempting to us? Well, minimal code duplication, obviously. Screens can be created using the same tools on all 3 platforms, backend, iOS, Android. That means we develop screens in the same way, both those that require a connection and those who don't, like our downloaded podcast view, for example. We'll also have full flexibility client side if we want to go to our entity-based API and hard-code the presentation in the app itself, or go to our presentation API if the screen requires some flexibility from the server. Versioning is also super easy with this approach. If you, for instance, have version 1 of the component library, you ask the server, and the server would know exactly which components are defined and which properties they have in version 1, since the server has the same copy. Now, how did we achieve this? Well, as you can probably tell by the name of my talk, we used Kotlin Multiplatform. Now, as you probably know, Kotlin is a language that was first developed to run on the Java Virtual Machine, or the JVM. However, now there's a technology for compiling Kotlin code to Kotlin native binary, and that technology is called Kotlin Native. Now, it's a LLVM-based backend for the Kotlin compiler. And Kotlin Multiplatform is an umbrella term for Kotlin JS, which transpiles Kotlin code to JavaScript, Kotlin JVM, and Kotlin Native. Now, there were some reasons why we decided to go with Kotlin Multiplatform. Unlike, for instance, technologies such as Xamarin, now I'm just bad-mouthing other technologies here, but they kind of force you to write the app using their own ecosystem and language. Now, Kotlin Multiplatform, or KMP for short, can be added as a framework and introduced iteratively. So we'd not be limited by any ecosystems APIs. So we could just use UIKit and Android features the same day they're released. Strongly typed Objective-C headers automatically generated. Now, Kotlin even supports optionality and more advanced stuff like closures, and these are easily bridged, actually, which was important for us due to us wanting to have our entities defined in this shared framework. No performance overhead. Unlike other technologies, Kotlin Native is native, and it doesn't run on a virtual machine. The team already had experience and were comfortable with Kotlin because we've been using this for very long, so we could just leverage the team's prior experience in Kotlin to get us off the ground fast. And since it's quite similar in structure to Swift, the process for us iOS developers didn't take so long. One thing to note, Kotlin Native can help you with a lot of things. UI components is not one of them. It doesn't have its own layout engine, and UI components are kept to be implemented in native, which we felt was a good thing. So we could define our views in SIBs, for instance, in iOS, and we could use XML in Android. So native tools, which we were used to in respective platform. So I'm going to give you a quick example of how we built our framework using the iOS client to get entities from this entity API, and this is just to get your minds flowing. So we have these view models that produce updates, and we're using Kotlin coroutines for this. And Kotlin coroutines is kind of like a RX replacement, so it has functions. This channel, for instance, that we use in the view model, it kind of functions like observable. And then we'd also have this view data repository here. Can be some kind of network call, just a list of entities or a call to the database. And we initialized it using dependencies. Now I'm going to show you these in the next slide, but here we use our listening history manager to get the time left and present it to the users. This is fairly easy. In this case, the screen just forwards updates it gets from the view model, bundled with the index of the view model. Also note the dependencies. So we have our player, we have our navigator, and our listening history manager that we just send in through. And I'll go more into these later on. And on client side, it looks something like this, that we take the screen and we convert it into a mutable copy, which is more like a view model representation that has functions that are similar to the ones present in a UI collection view data source. And the screen view models it contents also get converted to mutable copies, mutable view model. If you have a more complex layout, for example, our carousels that have a UI collection view inside of them, the UI collection view data source for this carousel is owned by the platform's mutable copy and set on the view when it will appear. The view controller subscribes to updates from screens and applies these on this mutable screen. And those of you with sharp eyes will notice that we don't use sections here, since that concept doesn't exist on Android. So we ended up implementing our own flow layout for setting things that would normally be done section-wise. So for Android, we basically do the same thing. So it's quite similar, actually, to both platforms. Now, if you would try to do something for the web, well, then you probably have to do a bit more differently. But so basically, our shared library. It will calculate the insertion deletions. Clients will take the first state and then subscribe to screen updates. It will then apply updates on these mutable view models. And we ended up implementing the view layer very thinly. So it's about just 500 lines of code. That is, of course, excluding the platform-specific things, the domain-specific things like the view data, views like the cells and the mappers, of course. We set up our build server so that it would create the Android library and publish it to Maven. And Maven is what Android uses for package handling, with a build number as the version number. And we'll also tag with the build number in Git. So we use these tags for Carthage. We created a dummy Xcode profile in the root, which only has a run script that creates the Kotlin native framework. For Carthage, it will look like any other framework. Now, if you use CocoaPods, I saw in some release notes just the other day that they now have built-in support for this. Although we haven't used it, so I really can't talk about it. So what can I tell you if you were thinking about building a shared framework using Kotlin? Well, start small. The classes such as listening history manager, etc., are still native. They're still written in Swift, and they're injected into the framework using this dependency class. And it uses core data to spit out entities that are mapped to the shared framework counterpart. Now, one might migrate over more and more code to the shared framework. For example, you might just generate SQL queries from the shared framework itself. I know many of you will not go home and thinking, wow, let me port this whole app just straight away now. So my suggestion to your doubters is just, on maybe a hack day or something, just put a skeleton in place. Talk about it when you start writing new features, like, hey, can we write this feature so that it's in the shared framework? And as your team becomes more comfortable, you probably figure out what would be a benefit to share in your product naturally. Now, think beyond your platform. Like I mentioned, avoid using concepts like sections. Also, since, for example, the application lifecycle is different between iOS and Android, we had to rethink how to implement reloading of the screen when you background the app and return it to the foreground. So our approach was just to have callbacks for reload in the shared library and letting the clients decide when to perform them instead of naming them view did appear, for instance. We also found it good, like a good thinking exercise, to think about platforms you don't support yet, such as web browser, and what these concepts mean for them. Few bridging points. Now, we put a lot of the logic in Kotlin. You might decide not to do this, but we felt that Kotlin native works best when data flows in one chain within Kotlin native. For instance, we chose to keep all view models in the shared library and do operations like diffing there. Remember, we're dealing with Kotlin native and Objective-C headers, so Swift structs can't conform to protocols generated. So keeping view models in Swift and adding diffing client-side, that would be a messy operation with equatables and whatnot, and this was built to avoid that. Also, generic support was not good in the version we started using, but that's changed since then. But that's what we built this framework around. Think about threads. Now, how concurrency works in Kotlin native is pretty different from both Swift and JVM, with the concept of freezing objects, explicitly marking them immutable before sharing them between threads. Effectively, this makes having a shared mutable state across threads hard. Now, we designed this with this in mind, so everything in the shared framework, diffing, JSON deserialization, etc., could be done in the background thread, and then we just send these immutable objects to the client, and that would switch to the main thread in the last step and apply the changes and switch over to and tell the UI to reload. Now, this concurrency behavior is subject for discussion in the Kotlin native community, and it will probably change, but that's how it is at the moment. So, the good. Now, we do a lot of mob programming, or team programming, as we prefer to call it here at Sveriges Radio, with some teams exclusively working in mobs. Now, mob programming is, for those who are not familiar with the concept, when a group of people code together in front of the same screen. This is simple explanation, I know. But not only was this a great way to introduce us iOS engineers to Kotlin, if your code bases differ a lot, and we noticed this, you will also, you will sit there together and find a common solution and start discussions about what is the best solution, what are we doing differently, and how can we do it better together. I'd strongly suggest if you do Kotlin native that you do something like this. Yeah, obviously, you introduce a better engineering process, you will promote code sharing, and you will solve problems across your platform boundaries. And also double the amount of conferences and meetups you can go to. So, we also found that this encourages solid design principles. With the architecture designed the way it was, it encourages solid design principles such as separation of concerns and using interfaces. You won't be able to drag in UIKit in your shared library, and that forces you to think about what you're really trying to achieve. Debugging, errors, warnings. Kotlin native will if the app crashes. I know you're all good programmers, so this won't happen, just hypothetical. It will provide you with a stack trace that tells you the line in the file where the exception occurred. If you have your source files included in the project, you will also get a red line in Xcode where it crashed. You can even put breakpoints if you use an Xcode plugin called Xcode Kotlin. Coroutines. Well, this is basically the RX of the Kotlin world. It works really good in the iOS world as well. In our app, we use RX Swift, and when bridging to and from our shared library, we've written extensions that map RX Swift concepts like observables and behavior subjects to their coroutine counterparts. You can seamlessly move behind the worlds. The bad. Limited standard library. Types like date and URL do not exist in the Kotlin standard library, so you have to use third-party libraries, make your own implementation, or offload this to the clients themselves. There is a mechanism for this, actual and expect, which is basically a platform-forward declaration, but then you lose the benefits of having the same implementation across platforms. Limited third-party libraries. Since we're dealing with Kotlin, we can't use RxJava, JSON, or any other libraries that are common in the Android world, since they often use Java under the hood. Now, coroutine serialization, they work awesomely as replacements, but still a lot of the libraries your Android colleagues are used to won't be working here. We couldn't, for instance, find any library that provided diffing, so we ended up deciding to write our own. Now, Gradle wasn't fun to work with for us iOS developer. Kotlin native uses Gradle, and for those who don't know, it's basically a fancy build script where you configure how your app will be built and which libraries it depends on. Now, take your time and learn how to use it. That's all I have to say about that. Coroutines. This might not, as the previous slide, it might not be a problem with Kotlin Multiplatform, but you know, remember when I said that Kotlin coroutines was their answer to Rx? Well, I lied. Some concepts are similar, but some are not. And if you try to pretend that it's the same thing, you'll undoubtedly get a headache. Now this thing, or should I say interface naming conventions, because that's what they're called in Kotlin. Now this is a heated topic already in the Swift world. It's an equally heated topic in the Kotlin world as well, as you'll probably find out if you do this. So now you have a bunch of different camps fighting about putting I prefixes, impl prefixes, able suffixes, you know, everything. And last but not least, this is experimental. There's no way of walking around this. Even if you use this, your editor will flash up in all shades of yellow and just tell you that you're doing a lot of experimental stuff here, and it is. Now, coroutines are experimental, serializable are experimental. Kotlin itself is also a pretty young language. But we haven't actually found a single bug yet that we could track down to Kotlin native. The biggest hurdles we had were mostly to deal with the tooling around it. And at the end of the day, we felt that this was good enough to put in production. And maybe this talk will make you think that as well. So that's all. Any questions?
Thank you very much, Narek.
Yeah? Do we have time for questions?
For questions, so I'll see one right in the back. There we go.
How is the binary size affected?
I haven't counted. But I think it only imports what libraries you are using, so I think it shouldn't be so big. But yeah, we haven't really checked into that.
Boring question. Does it also force you to disable bitcode?
There is a way to enable. No, it doesn't. You can embed Bitcoin code with it. Yeah, so that's possible with Bitcoin. Yeah, we also have a Bitcoin miner in the app. I forgot to tell you about that.
Any more questions for Narek? Nope. All right. Well, then, thank you once again. So, did we have Tobias Löfstrand? Yes. Oh, great. You arrived a bit late, but we're super happy to have you here. So, let's just get you mic'd up and ready to go. Ja. Ja, det är det. Narek, vilket headset var det? Det här eller där? Vi kör på det.
Varför la vi alla på exakt samma sätt?
Ja, jag vet inte. Janne kommer inte bli glad alltså. Så.
Mirroring eller cloning?
Du kan köra bägge och så ska vi sätta på den här. Så kan du ha den i din bakficka.
Ja. Är den på nu?
Japp, den är på. Kör den då.
Okej.
Sådär.
Ja, det funkar naturligtvis inte.
Testa att sätta på den nu då.
Så, bättre.
All right, give it up for Tobias.
Thanks a lot. This is my first presentation here at CocoaHeads, so I'm super psyched. And especially since it's a 100th anniversary, what could be better than that? So anyway, my name is Tobias Löfstrand, and I'm here today to talk about interfaces, styling, layout, and the quest for better developer and designer collaborations. Just a little bit quick about me. I've been doing iOS development professionally, at least, since 2011. Back then, it was, of course, not these fancy things with Swift and Arc and all of that we have today. Simpler times. I've been at the company called IT-huset since 2018. It's a consulting company doing all sorts of system development consulting, and of course, mobile consulting as well. Before that, I spent a longish while in the Java and the web development community. Actually, all the way since 1999, I started my journey. So I'm kind of feeling old now. I'm not sure if I should, but... also, one of my obsessions is Iceland. So you're bound to see a few of these like volcano pictures and other fun stuff here. So Iceland and photography in general, that's an interest of mine. And of course, creating beautiful user interfaces. That's my passion when it comes to my profession, at least. So it fitted kind of well that I created this framework called Interfaces or InterfaceCSS, depending on what you want to call it. So what is InterfaceCSS really? Well, it's at its core, it's a framework for CSS-based styling. So you use the same like CSS language that you're used to from the web to style your UIKit-based applications. So currently both iOS and tvOS actually in a limited fashion. But it's more than that. It's also a layout framework using an XML-based layout language. And from this beta version of 2.0 right now, the actual layout language is CSS Flexbox that you use to express your layout constraints and stuff like that. It also has fancy things like hot reload for creating a good developer experience and increasing productivity. And also fun stuff like theming and adding lots of different style sheets and stuff like that. It recently turned 5 years on GitHub, but it's been fermenting for a longish while, later than that actually. But I forgot to actually make a happening out of it, celebrate something, had to do that. Anyway, the motivations behind creating InterfaceCSS from the beginning was really the need to get a consistent styling of your iOS applications. So instead of like sprinkling your styling code or styling set up in all sorts of nibs or storyboards or even in code sometimes, You want to have some central place of putting all that in. And of course, I worked in a bunch of apps in the beginning where theming was a big thing. So light themes, dark themes, and sometimes funny, colorful rainbow themes that might be fun when doing demos and stuff. And easily switching between themes was a big, important thing. And of course, the need for styling to be dry, that is, don't repeat yourself. And also accessible. And accessible, then I mean accessible for other than developers. So like designers, for instance, and most importantly, designers. So they can feel like they are part of the design, that they own the design in a better way. But also a lot of other motivations. One interesting, not to forget, aspect is curiosity-driven development. Sort of the urge to create something new and try to learn something in the process. And also things like frustration-driven development, where the tools kind of get in the way and that doesn't really do the things you want them to. But also a place to like sharpen the saw, to exercise, try new things, things like that. But of course, most of all, to increase the collaboration between designers and developers. So you like share a common philosophy, and if you work with a designer and a developer that has the focus for like pixel perfect, beautiful user interfaces, then this might be a really good thing. And also, if you're interested in like design systems and atomic design and things like that are more CSS close, this is where InterfaceCSS can help. But when you work with designers, it's good to have a common language, and what's more typical of a common language than CSS, basically, ubiquitous language for design, at least on the web. So at least for my part, I've worked with designers that also work a lot with the web. So they know CSS and HTML, if not for prototyping, making their own prototypes. So CSS fits kind of well as a good design language. So in the beginning, interfaces was kind of simple. It had simple CSS selectors, tried to mimic the structure of CSS, but didn't do any kind of more fancy tricks than that. It used the same property names that you used to in iOS development. So it was like background color without the dash and stuff like that. But it also had the aliases, so you can, if you come from the web world, you kind of use the same property names from the web world. They map over to iOS nicely. At times, it kind of went a bit overboard with trying to implement sort of the whole CSS specification. Not quite there, but eventually support for selected chains, pseudo classes, and other fun things like that sneaked its way into interfaces. And also sort of CSS preprocessor features from less and Sass, for instance, like variables, nested declarations, and things like that. But anyway, well, yeah, that's a small sample of how the CSS can look like. And it's also support for setting things like if you have control state on a button, for instance. So you want to set the title color for the highlighted state and also the normal case. So that is also handled in the CSS file. But before you can have style sheets, you have to have some kind of way of parse the style sheets. So that's been kind of a journey in itself. And I started out with using a framework called ParseKit back in the day, which is a grammar-based framework. Can't really remember why I switched, but it didn't really fit my mindset. So I switched over to a framework called Parkoa, which is more of a parser combinator framework. It sort of uses a composite pattern to composite small baby parsers together to more complex parsers. And that kind of fit my mindset a bit better. But the performance was kind of so-so. So eventually, of course, curiosity-driven development. I had to develop my own sort of micro custom parser combinator framework that's currently embedded in InterfaceCSS now, but probably will be externalized. But it's, yeah, basically an easy way to chain small parsers together and get something more complex. And my custom framework smoothed over some rough spots of the Parkoa framework, which had to do with string handling, basically. Especially in Objective-C, that was an issue with passing strings and copies of strings and constantly making copies. That was very expensive, so I had to change that. That was styling. And then we have layout. which is the other important thing. But before we talk about layout, I have to mention that like UX, usability, best practices, that's kind of close to heart for me. And within like usability, you talk a lot about cognitive biases. And one cognitive bias that's really important is kill your darlings. And I think this is something that every developer, designer, and everyone really should bring with them. That you shouldn't stick to something that you used for a longish while just because it's there. So I started questioning interface builder. But long before that, I actually used other WYSIWYG editors. So this is an example with in the Java world, JBuilder. Kind of used that for a while, but then you realize that the code that it generated was kind of bad. So the community kind of moved away from WYSIWYG. So when you entered the iOS world, I was kind of surprised that you got this Xcode interface builder thingy, which worked pretty nice in the beginning, but eventually it started getting sort of clunky, bad performance, not really smooth to work with. So circa 2014, this frustration-driven development really came into play here. And that kind of made me want to do something by myself. So my first attempt at layout was to create a simpler auto layout, basically, which was also a constraint-based layout thing. But it was substantially easier and substantially better performance at auto layout at the time. But of course, it was not standard. So right now, in Interface 2.0, I'm looking at CSS Flexbox instead as the design and layout language, which is a CSS, more ubiquitous. So it's much easier for designers to get into. And of course, there's a great engine, Facebook Yoga, that been discussed here at previous CocoaHeads meetups. So that's what's powering Interface right now. And I'm just going to go quick. Time is, it's hard with time here. So styling and layout. There's a good tutorial on Yoga framework by Ray Van Lich, and they have a good case about that as well. So I've seen this happen a bunch of times, that you try to copy a good sample code case and make it your own. So, of course, made the same journey myself with InterfaceCSS. And so there's a sample code called Flexivistas. I'm not going to go into detail about it right now, but it, of course, is Iceland focused, as you can see here. It's sort of a Netflix clone, but it showcases what you can do, basically, when it comes to binding layout code from your XML file, basically. So this is a short example of what a layout XML file can look like, where you can specify inline styles for Flexbox layout. And you can also specify names to bind things back to your view controller, for instance. There's still lots of things to do, like better testing, automation, documentation, action bindings for like button clicks and whatnot directly from the layout. Maybe Android support to create something really more cross-platform would be really great. Had a sort of a mini rant here that I'm not going to go into detail about, but suffice it to say, I think it's lots of interesting things happening on cross-platform, especially in frameworks like Flutter. So native really needs to keep up. And the presentation before about Kotlin Multiplatform, that's a huge thing, I think, in this area. And InterfaceCSS tries to be another part that's handling the layout. At least that's a goal long term. Anyway, it's not trying to be a solution to rule them all. I mean, this does require some knowledge of CSS and Flexbox, so it won't fit everyone, and every designer for that matter. And who knows, at WWDC, maybe this will all be obsolete because Apple will have introduced something much, much better. You can keep our fingers crossed or something. Anyway, tack, and see you at WWDC.
Thank you very much, Tobias. Do we have any questions? And also, I'd love to have a comment from Jonas Salling later on,
Yeah.
who had a talk on the yoga framework earlier.
It was a very interesting talk. Thank you for that.
Thank you.
My question is about performance.
Yeah.
What are the performance characteristics of interfaces?
Well, as I said briefly, I've worked a bit on the CSS parsing performance. So I think I've kind of increased the performance of parsing and loading CSS files like 100 times by just implementing my own parser framework that went away from this string management that was pretty bad in this Parcoa framework. And I'm actually right now looking at implementing in Swift, so maybe I'll get even more better performance increasements there with the better string management in Swift. The loading of XML files, it's done with the like standard XML parser right now in iOS and macOS. So I think that's pretty decent performance-wise. And usually those XML files aren't that huge anyway. And the way it works right now, it's that it's first parsed into like an abstract method, like a virtual representation of the UI, that then can be reused to create multiple views using the same like definition.
So follow-up.
Yes, a follow-up question. What I was really wondering if Interfacss is suitable for situations where performance is like a requirement, like where it has to be 60 FPS, like where we have table views and reuse cells.
Yeah, definitely. It's. I mean, I've used it a bunch of times in a bunch of projects with table views, and I mean the styling isn't really applied all the time. So it's kind of some logic around that when styling needs to be applied to a certain element. And it fits quite nicely together with the cell reuse with table view and other such views. So that's usually not a problem. And there are ways of improving performance. When you can use unique identifiers for things, and that optimizes caching a bit better. So interfaces can cache style information more effectively if you use a smart element identification scheme. So,
any more questions for Tobias? And maybe Jonas, if you would have a comment. No comment from Jonas. All right. Well, then, thank you very much, Tobias.
thank you.
So now we have a small break in the schedule. I think we can be back at 20 past, so in 13 minutes. And we're going to be back with fireside chat and our last presentation for the evening.
Tack.
Soon, maybe. Now. So welcome back, everyone. Now it's, since this is our anniversary event, we've invited some very special guests tonight for a fireside chat. So first, please welcome up Leo Giertz, one of the original founders of CocoaHeads Stockholm. Kan ta en mikrofon. And next up, we have Nevyn Bengtsson, also one of the first members, and will be speaking later tonight. Can take a seat. We have Marthin Freij, who is organizer before me. Please welcome up Martin.
Whoa!
And of course, we also have another Martin Andonovski, who is our new member in our organizational team. Welcome up, Martin. So it's a little bit cozy here in the sofa. Yes, everybody has a mic. Great. All right, so maybe Leo, you can start off with,
Okay.
like how did this all get going?
So there was basically no community for Mac and iOS developers back then.
Yeah,
This
is
was
your
in.
mic?
Is it on? Can you hear me?
Yeah.
Yeah. So this was back in 2008, and I'd been at Spotify doing the first prototype of the iPhone app, and after that, we realized that there wasn't an SDK back then, or like no tool chains or something like that, and there was just a few companies doing Mac stuff in Stockholm, just a handful of them. So there was basically like no forum for us to discuss and learn from. So me, Rasmus Andersson, and Mattias Arelid, both at Spotify, got together and thought, okay, we should start a group, and then we had heard of CocoaHeads and read about them online. So we started the Stockholm chapter, and we had the first meeting 2nd of June 2008. So that's 11 years ago. And we were 4 people at the meeting. It was me, Mattias, Rasmus, and this other guy who found us from the CocoaHeads website. He went on the name Ylan. So he was one of the first members. Yeah.
That's cool. And there's also some interesting connection there, right? Because Nevyn, you were working yourself on an iOS Spotify client, am I right?
Yeah.
Before.
So
And we actually met at WWDC.
that year.
Yeah, that year.
That's right.
Yeah, and I couldn't tell what I've done, and I knew that you built this hacked version.
Yeah.
And we actually met and talked a bit. Yeah.
Yeah, that was funny.
It was funny.
Yeah, me and a friend, we both loved Spotify. We were in the beta way back. Voxer is also CocoaHeadser. So yeah, we built it on Spotify, this reverse engineered version of Spotify's protocol.
Which was much nicer than the actual client.
Yeah, so
It
yeah,
actually
we got our app out before yours, I believe. So
Yeah. Well, actually, the real one was yours as well, right?
No, that
No.
was another team.
It was another team who built the first actual app.
Yeah.
Because me and Jesper did the prototype. And
Yeah.
then Jesper built like the actual app.
It was Arelid, I believe.
Oh,
No?
really? No,
Yeah, I don't
Jesper,
know.
no. Yeah,
Just
I think
Jesper?
Yeah.
Okay. Well, and then I took
Okay.
it over like a month later.
Yeah.
So yeah.
So at this point in time, like there was this larger CocoaHeads organization, but there was nothing like Meetup.com to kind of
nothing.
like show the world that you exist. So how did you recruit your first members?
So we actually, CocoaHeads, they had our super crappy website. It was horrible, but we registered there. And so one person found us for the first meeting. And then it started spreading, actually. Jack, I think you joined like in June, pretty early. And you were about to show up for the second meeting, but you bailed last minute. And then I was actually going through the old emails. And then you were about to, you said that you're going to come on the third meeting as well, but bailed as well. And then in between meeting 2 and 3, I think Edward Patel, he became a member. So he might be there before you. Yeah. We're pretty close, yeah.
Jack, do you have any kids about 11 years old, 12 years old?
Turns out I had young kids then.
Okay, yeah. Yeah.
As good an excuse as any, right?
No, you're actually coming down from Fjällen, but got delayed.
Oh, okay.
Yeah. Yeah.
All right, and then in the beginning, like at what point in time did you join Marthin?
Actually, my first contact with CocoaHeads was also in 2008.
Yeah,
but
in the fall, right?
Yeah, in the fall, in November, because at the time I worked at ICA Banken, and during that spring in 2008, there were rumors that the iPhone would be released in Sweden. So we started like building an iPhone version of the internet bank to be the first iPhone internet banking app in Sweden. But we didn't build it on Cocoa and Objective-C and stuff. It was a web app.
You're supposed to do these kind of clips first, right? Where you would
save
an icon.
Save an icon, and But it was actually pretty nice, and it was a quite hard UX challenge to take a full-size internet bank and scale it down to mobile. And so my first contact with you, I guess, was to ask if I could do a presentation at meeting number 5, I think it was. Yeah. And we talked a lot about how we thought about scaling down a full-size internet bank to a pocket-size iPhone experience.
This was actually kind of a big question back then, how to fit things in a mobile phone. Yeah. Because, I mean, the ordinary or the standardized computing experience was on a desktop, right? Yeah. And you had to kind of take all the functionality and figure out how to fit it in your hand. Yeah.
And the first versions of the iPhone SDK was pretty limited, so you couldn't do that much. And so I think a lot of discussions was around the device itself and what can we do and how can we use it, and try to come up with the idioms that we used for several years later. So it was pretty exciting. I think there were 5 people at the meeting when I was there.
Yeah, so we grew almost 100%.
Yeah,
it's like a hockey stick.
Yeah, but then I fell out from CocoaHeads for a while because I didn't do any active iPhone development at the time.
No, you're doing C#, right?
Yeah, sorry. And but I can't really remember when I came back. 2009 or 10 or something.
Yeah, we can check the archives and see.
So back then, when you were just starting out, you didn't have these fancy big places to be at.
No. So we were at the meeting room at Spotify for the first meetings, and I think at a company I worked at called Bamboozer. Yeah, we also just hang out there. But we were 8 people or so at those meetings, so we could be basically anywhere.
I actually remember a meeting at Bamboozer, and Jack did a presentation about the Sticky Man game or something. Yeah? And you told us about the story of how to publish an app in the App Store, and it was mind-blowing how complex it was to publish apps in the App Store.
Yeah, and that was also before all of that certificate management was automated. It was really painful.
Yeah. And
so you kids, you have it easy today. And I didn't even have an SDK when I started doing iOS stuff. Not even a tool chain.
And just trying to understand the tax report forms and stuff.
Yeah.
That was really hard.
So at what point did you start with this format of going from place to place and having new sponsors every time?
I think it was pretty early on.
Yeah.
Between Spotify and Bamboozer. And the first meeting I attended to, we were at spårvagnshallarna.
Yeah,
there was some iCube.
So the old iCube office. Yeah. So we were sitting there. Yeah.
So I think that was from the beginning, jumping from office to office.
So the iPhone became a hit, and this entire scene exploded, right, in 2009 and so, and everybody needed a mobile app. So there was lots of companies that were willing to sponsor events and so on.
Yeah.
I remember one of the first rules. I think you came up with it, that you can't mention that you're hiring people if you don't buy beer.
Yes, exactly. That was a recruitment policy. Yeah. So in order to post on the mailing list or announce at a meeting, you have to pay for the beer.
Yeah. So that was basically how you started the whole sponsoring thing.
Yeah. Yeah. Because I wanted to avoid the recruiter spam and so on. Yeah. And also, beer is nice.
Yeah, we can all agree on that. But I also think that this entire format of us always going to new places has been really a pillar stone of the meetups. Being able to have a look, if you're a developer working somewhere, to be able to have a look at how people work with iOS at different places, right, and in different team constellations and different office spaces, different technologies, although it's all tied together within the Apple ecosystem.
Yeah.
And I think I remember that back then probably in 2008 or 2009 or something, Apple did some tech tour at KTH.
Yes, they did.
Very early on, and that was, very in the beginning.
It was 2010, I think.
2010.
Yeah,
Okay,
I think
cool.
so.
Yeah.
I was 3 then.
Yep.
Right.
It was actually much better than 2.
Yeah. So how long did it take you before Marthin started to run the organization?
I don't remember the date, but I remember the venue because you had planned a meeting at Skype, and you were so busy building RAP, setting up the RAP company, and you really couldn't make it. So you called me like 15 minutes before the meeting started. Yes. Hey, can you just say hi to everyone? And I think there are speakers coming, and there should be beer. So okay, I can do it. And then it just, you were busy, and I took over.
I don't remember this at all.
But
it sounds it sounds very plausible because I was super busy.
Yeah,
it was really hard to co-found a startup and also have time over for other things because they tend to kind of eat all the time you have available.
Yeah, for sure. And that it seems to have become a recurring theme, as we were discussing earlier among the organizers, because later. What happened?
When I started my company and got really busy there, I handed over to you.
Yeah, exactly. I remember it was at where I was working before at Ape Group, and we had some really grand plans to bring some external speakers and really make it a big event, and that kind of collided with you having a lot of things to do at the same time.
I think it was during the launch of Apple Watch, because we were traveling back and forth to Cupertino a couple of times, and we were very busy. In the Apple Watch labs and stuff, so it was very busy times.
Yeah,
and I had a kid, and and that takes some time as well, a newborn.
Because you were there doing, was it a Green Kitchen for the watch, right?
Yes,
and doing before they released it.
Yeah. This I don't know. I don't think it's confidential anymore. But Apple reached out to us in early fall. I think it was just after the September event when they announced that they would release the Apple Watch. And they reached out to us and asked if we could come up with some interesting concept for the watch. And we had our veggie recipe app, Green Kitchen. So we just imagine how cooking would work on a watch. And we did some really rough sketches and sent them over, and they got really excited and wanted us to come over to Cupertino more or less immediately. So we went there just a few weeks later, and then took some weeks, and then we were invited back, and I think we were there three times or something. So it's quite busy.
It's really interesting how these effects and what's happened with former CocoaHeads alumni and people in the network. Like we've had a few members joining Apple, David Rönnqvist, for instance. He started off with doing some presentations here, and then he became this international speaker with and writing a book about SceneKit, and suddenly he joined Apple. And it's kind of the same story with John Sundell as well.
It's with David. It was actually quite fun because the meeting that you set up at Skype that
didn't make it to.
That you didn't make it to. That was the very first time I met with David, and because he worked at Skype back then. We took we went from there together or something. I don't remember, and I really pushed him to do a talk because I noticed that he was so awesome at the animations and stuff. So I said, "You really have to do a talk at CocoaHeads," and he was very nervous, and I can't really make it. And So I really pushed him hard and said that just do a very beginner's thing. And then he did the most amazing talk at, I think it was at Hokaboka. He did his first talk and it was just amazing. And then he started a blog and wow, that guy.
Yeah,
awesome.
yeah, that really went off the charts.
Yeah.
That blog is still a gold mine. He's amazing at core animation.
Wow.
Like I've learned most of my stuff about core animation from his stuff. So
Yeah.
Yeah, and also like basically the same story with John, right? He was starting off with his own presentation about his own game framework, game engine that he built, that he later open sourced like a few years later at Spotify. And like right off the bat, like you could see that he was a great presenter. It's been really fun to see him really take the world stage from there on.
There are so many examples of great things coming out of CocoaHeads Stockholm, I think. I totally lost it. Sorry. But Nevyn, you announced the look back at CocoaHeads meeting, I think.
Right. Yeah, I think we had a cross. Like, it was at Spotify. Let's see. Oof, that was a long time ago.
We're getting old.
Sorry?
We're getting old.
Yeah, we are. Yeah, was it? It was not a dub event. It was somewhere around there.
I think it was one of our biggest events ever. It was one of those times, like back in the days when Spotify would invite like 250 people and give like really nice burgers to everyone, and we were like, okay, this must cost a fortune, but
and then we announced we went out of I guess we went into beta and a public launch and let people use the look back tool. I think it was iOS only back then. But,
was it a meeting with Matt Thompson as well? The really big thing at Spotify?
It must have been, it must have been.
Yeah, because we invited Matt Thompson who did AF. I think he announced AF Networking too at that meeting as well, which was pretty awesome. Also, I remember a guy called Henrik Lenberg who worked at SoundCloud, contacted me, I think, or me. And wanted to just pitch an idea because he
was it Oxy or
so he pitched that I don't really know what I want to do, but I want to build some kind of music app. And then he found some guy at CocoaHeads and they started a company together and built Oxy, and Oxy got a design award, an Apple Design Award 2 years ago, I think, or 1 year ago or 2 years ago, which is pretty awesome.
Yeah, that's super cool.
There are a lot of great stories.
I was actually supposed to do my thesis project with Henrik regarding creating music in new ways and so on.
Great.
Yeah, that's really cool. So, Marthin, you're the newest member in our organizational team. How long have you been part of the community here in Stockholm?
Can you hear me? So I've been here for 3 years, actually 3 years ago, and the first meetup was, I don't remember the venue, but it was called Asynchronous Swift that I attended. It was so awesome. There was a bunch of speakers from the UK. They spoke about asynchronous development, and I was hooked the moment I saw it. I've never missed the Swift event since then, mostly CocoaHeads, and I'm very honored actually to be in the company of you guys. It seems like you guys done a lot for this kind of community, and it looks like there's high expectations on me. I hope I can kind of keep them up.
I remember that one because it was us at Doer who hosted it that time. It was a really great event. Like we had, I think, Thomas Visser of Bright Futures, and we had somebody else doing RX, I think, and Dan Thorpe of Operations, or was it Operation Kit or something? It's really cool. And something that we haven't announced yet is that just as Leo stopped having time for CocoaHeads when you were starting your company, and Marthin had the same issue. I've also started a company during this spring. So as of today, I'm going to be handing over to Marthin. So I think please give a huge applause for Marthin.
Thank you very much. I hope I can actually earn the applause, not just kind of get it preemptively.
Yeah, I think it's going to be really great. And you already organized the last meetup we had at ISATL. So now we're going to have a short break during the summer, right? But then back in August or September, we're going to be back. Except for the WWDC meetup, of course, which is going to be next week.
Wow, you've done amazing work. I think you're the one that run this way longer than anyone else. It's so impressive, like 50 meetings or something.
So how long do I have to start a company then?
A couple of years.
Yeah, the clock is ticking.
Probably 3-4 years.
And it's all downhill from there.
Okay, so learn from others' mistakes, or?
Yeah.
Yeah, I mean, it's I joined in at meeting 54. And
wow.
Yeah, and the 101 next week is going to be my last. So it's been a few. It's been a few.
Wow, yeah. That's
Which one? Which meeting are you most proud of?
Oh, that's a really tough one. I think like any of the bigger meetups when we had international speakers, I think it's really fun. Every time we can like pull a really great name, and being able to like use some sponsorship. Like after we set up the job board, we could get some money in, which we could pool for later events. But any of those with like Orta 3 Rocks or
that was the first time I spoke actually.
Yeah, at Sub 46 when there
it was a great event. I'll never forget it.
Yeah, well, I think all of those have been super cool, and also when we had the 1,000 member party at the Bambora.
Yeah, I remember that.
Yeah, that was a fun one.
Yeah, it was so crappy in the beginning, and then it got so professional. I'm really impressed.
It had space to improve. It was never crappy.
Well, I mean, the logo is still crap because it's the same logo, you know.
Oh, but this logo actually is the. It's in some ways the original logo.
Yeah, but it's slightly modified. Yeah.
Yes, because Rida of Stockholm Swift, he did a redesign when we were gonna print stickers.
Oh yeah.
And we were like, okay, we can't print this.
No, it was too crappy. Yeah, it was too crappy, right? Yeah. So this one's way nicer.
I really like this rendering actually.
And I think we got a question. I got a question from you, like, why the heck, why is there a lion?
You're like, don't ask.
And the only reason I can come up with is Leo.
No, but I didn't do the logo. I think. Okay. No, I'm innocent actually.
Okay, so first job, redesign the logo.
Yes.
You
can just ditch the lion.
Yeah. Cool.
No, I think now we had 100 meetups and probably. We have 100 more, right, under Martin's lead, and I see we have there's so much more things that we can do as well, and like now that the community has been growing, and we have like an offline or in between channel with the Slack group, I think a lot of things can be done to improve collaboration, improve diversity in the community. Maybe reach out to schools and help out with like forming education around mobile development. And I think this community has a lot that it can contribute. So I really look forward to the coming future.
On the note of diversity, actually, I'm the first foreign-born person that's gonna organize CocoaHeads.
Oh, actually not.
No,
because I'm born in Russia as well.
Oh,
so.
okay.
No. Almost.
You speak natively Swedish. That doesn't count.
Yeah. Oh well, I think it's time to move on to the program. So with that said, thank you all of you in the panel for all the contributions that you have made to the community and for being here tonight. And we have some cake for later. And now I'd like to welcome up Nevyn on stage for his presentation on metal. Give it up for Nevyn.
All right, just gonna set it up. Oh, man. Well, that's more like it. All right. Hey there. I'm Nevyn Bengtsson. I used to speak at CocoaHeads quite regularly, but that was like a decade ago now. It was definitely a lot less CocoaHeads attendance after I started my own company and then moved to the US. Yeah, but I'm really delighted and honored to be invited again, so thanks, Alek, for grabbing me. Yeah, so I'm really looking forward to talking to you about metal. I started out my career at Spotify, as you heard, releasing the first iOS app. About 4 years after that, I started a look back and announced it at a CocoaHeads event. Look back is a UX research platform. So what we enable you to do is basically to place a video call to your users. So you can interview them and do sort of more a deeper analysis and study of how people react when they're using your app rather than just looking at numbers. Needless to say, writing live streaming video and doing all that stuff means I write a lot of video and audio code. Last time I was here was 1 year ago at CocoaHeads number 87, where I did a presentation on LB Media Toolkit, where I was hoping to release a lot more code than I did. That was part 1, talking about how to do low-level media capture on iOS. And I did release some source code. I hope to come back here for number 2, but I never got around to that. I hope to do that sometime later. But rather than talking about capturing video and processing video, today I'd like to talk about displaying video. I'm doing that with Metal. So Metal is Apple's low-level framework for talking to the graphics card in Apple devices. It's generally used mostly by game programmers, but Apple uses it to display every single pixel you see on all your phones and Macs. And it's used for a bunch of different tasks, like all the ML stuff, like the AI stuff, is all based on Metal. So it's really powerful for a lot of things. Well, lucky for you, I don't listen to metal music, so I'll save you all the puns and cheap jokes. But if you're a game programmer and you're familiar with graphics programming, there are so many tutorials and guides out there to help you get started with Metal. But if you're just a regular old iOS developer writing apps, you might not think Metal is for you. I happen to have studied game programming at uni over a decade ago now, and thought I'd become a game programmer before iOS came and ate my career. So when I encountered an image rendering problem in my iOS app, it was pretty clear to me that I could solve it with Metal. So my presentation with this goal is to give you the basics tools to use Metal in your own apps, even if it's a completely 2D apps with no game mechanics. But luckily, if you're an aspiring low-level game developer, the technologies and techniques I'll show you will still be applicable, so plenty of material for you too. Bear in mind, though, I started game programming over a decade ago. I only do hobby game dev. And this presentation, it came out of me wanting to share my recent learning experience. So I'm no metal expert. But I really want to share the joy of low-level graphics programming. With that said, let's start off. So my problem is this. Me and my colleagues have been rewriting our iOS app called Participate from scratch. We used to use this Google framework for doing live streaming video called Google Web RTC. But we're deathly tired of it, really quite hate it. So we built our own live streaming protocol for streaming video and doing all that low-level stuff. But that means we can't use any of Google's tools anymore for doing, like, actually presenting incoming video onto the screen. Not only that, it's not regular RGB data, but rather YCBCR data, which is the native video format you'd use when you decompress or compress video from H.264. So it's all very low level, and there are like very few tools on iOS to deal with this. So it's quite hairy, and it's a lot of data. Like, if you imagine an incoming screen stream or video stream, it's going to be megabytes every second. So you got to do that quick. So just as a reminder, in case you weren't here at my presentation 1 year ago, to the left, we got some RGB data in different formats just to visualize what that sort of data looks like. So that's what you got in your UI image or CG image. It's going to be some of that stuff. You got bytes of red, green, and blue and alpha after each other. When you work with video, you use YCBCR, also known as YUV or YUV or 420 or 422 or I don't know. There's no standard name for it. It's planar data, which means that there's a plane of light values called the luma. That's the first block of data that tells you how bright that pixel is. And then there's 1 or 2 additional layers with color information. So that's what that looks like. And there are very few tools for it in a standard iOS framework. So you're going to have to convert it if you're going to display it on screen. That's going to be a problem. My first naive approach was to look at Video Toolbox, which is an amazing framework for video. And it has a VT create CG image from CV pixel buffer. And you figure, great, I want a CG image. Let's use that. So I did that, drew it with DrawRect, and that's awesome, right? No. That's a single video stream, ate the entire phone. So that's not going to work. That's not going to cut it. Well, why is metal the solution for this? Well, so graphics cards, also known as GPUs, what they do is they deal with massively parallel data processing. It basically runs a function for every pixel on your screen for every frame at like 60 or 120 frames per second. That's an insane amount of computation it does incredibly efficiently. So if you want to convert from one image format to another in real time, it figures that the graphics card would be good at that. Another thing is we want to use the GPU to display the video later. So if we convert it on the GPU, it's going to be on the GPU when it's in the right format. And so we don't need to transfer it back and forth between the CPU and GPU. And it can all be rendered. And so we save a lot of bandwidth inside the phone that way too. So awesome. Let's use metal. What do we need to know to use metal? Well, I figure these topics are topics that are good to know. So now I will teach these to you. All right. Let's get to it. There's geometry and vertices. There's like textures and UV coordinates. There's the pipeline of how stuff goes from your data to the actual screen, how to use the metal API to draw stuff. And then you need at least an inkling of what a shader is. So let's see how this works. Let's start out with geometry. So the geometry describes the 3D shape of objects. Everything you see in a 3D scene, in a game especially, but probably in any CGI, is composed of triangles. This is a stylized graphic to make that very obvious, but all graphics is usually triangles. There are some other techniques, but mostly it's triangles. A collection of triangles is called a mesh. So the whole thing here is a mesh. And it's composed of a bunch of triangles. And if it's something realistic looking, it's going to be millions of triangles instead of hundreds of triangles. Each triangle is, of course, has 3 points. You have 3 points to make a triangle. So in computer graphics lingo, that's called a vertex. So each point at the corner of a triangle is called a vertex. And each vertex has 3 coordinates because it exists in a 3D space. So it's got its x, its y, and its z. So it's got 3 numbers. So you got meshes composed of triangles, composed of vertices, composed of coordinates. That's geometry. That's the data you need to be able to represent 3D graphics. So let's look at how you represent that in code. So I'm going to visualize that by looking at these 3 pretty triangles right here. So it's pretty basic for the first triangle. You connect A and B and C, and suddenly you have a triangle. But thing is, a lot of times when you work with meshes, triangles will be edge to edge. So there is an optimization you can make where you say, after the first triangle, when I add another point, that's going to make a triangle with the 2 previous points and a new point. So just one more point creates an entire new triangle. And again, with the 5th point, you get a 3rd triangle. So that's pretty neat. You can get 3 entire triangles represented with just 5 coordinates. So that data structure is called a tri-strip and is very common in graphics programming. And I just think it's really pretty, like fundamentally pretty. So in code, I'm going to go ahead and create one of those triangle strips. Metal is really low level, so we're going to have to create our own classes representing this stuff. So we create our struct vertex. I am going to display a boring camera feed as a square on the screen. So I really don't need a 3rd dimension. So I only have x and y, and they're floats, floating point numbers. Graphics programmers don't say squares, they say quads. So quad is then 4 corners, bottom left, bottom right, top left, and top right. And together they form 2 triangles in this triangle strip. And I just create my quad like that, just creating 4 vertices. All right. So there we go. Yes, so a vertex though. Here it's just 2 coordinates, but a vertex can be so much more. At each point in a mesh, you might want to represent some other data, like the color the thing should be at that point, or some lighting properties, and also information on how to apply an image, called a texture in graphics lingo, to it. So textures, we're going to want a texture, like our entire purpose here is to display an image onto that square. So we're going to have to learn about textures. So an image, textures are still just regular old PNG images or whatever. They are like square images, and you're going to map them onto what is usually some sort of shape that is not flat. So how do you map a flat image onto something non-flat? Well, it's a little bit like origami. Each vertex maps to a coordinate in the image. Because we already used the variables x, y, and z to describe spatial coordinates, like where the thing is in space. We can't use x and y to say this is the position in the image. So instead, they call those u and v. So u is the horizontal and v is the vertical. All right, that works, I guess. So mapping from the texture onto the cube is called UV mapping for that reason. So here is a basic example that it's actually wrong, but let's pretend it's not. The texture is there on the right. So the easiest way to map this out is just to flatten the cube into this sort of flag shape. The UV coordinate 0, 0, 0 is going to be top left, and 1, 1 is going to be bottom right. And then at each vertex, I say a UV coordinate that maps onto this image. And that way it sort of transfers over to the geometry. A cube is a pretty simple use case, but this applies for any sort of UV mapping. So yeah, let's transfer that over to Swift. Our vertex has spawned 2 more instance variables called u and v, and it's suddenly 4 floats. So we've got the x and y to denote where in space it is, and we've got the u and v to say where that position in space maps to a texture. All right, that's our vertex. And that's the input geometry we need for this application, which is going to display a square in metal. I said this was low level, right? Right, so what's next? Well, we got this data. We want to mash it over to the graphics card. How do we do that? I made a diagram. So the red boxes here, those are your code. Your app is running in Swift over here in the leftmost red box. In Swift, you're going to write your business or game logic, and that's going to dictate what sort of geometry and textures and variables and stuff is going to be mashed over to the GPU. And then you got 2 more pieces of code called the vertex shader and the fragment shader. I'll get into what that actually means later, but those are written in the Metal shader language, which is by far the best shader language I've used so far. And that'll run on the GPU. So like you're writing code for a completely separate kind of computing engine in your phone, which is quite exciting, actually. So let's see. Well, so I'll explain how the vertex shader works later, but that's how where it transforms the sort of geometry that we want to display into geometry that maps onto where it should be on the screen. And then the rasterizer, together with the fragment shader, turns that geometry into actual pixels, which is then displayed on the screen, at least for a simple pipeline like this one. In advanced games, it's much more complex, but this is what we get away with. Now that we have a rough understanding of that, let's set that up in code. It's not that hairy, thanks to MetalKit. MetalKit accompanies Metal and lets you set up a Metal pipeline for your app, and is really flexible. It doesn't matter if you're writing a UIKit app where you just want to pretend it's DrawRect, or you're writing an entire game engine, you're implementing Unity on your own. It's really flexible and lets you implement whichever pattern you want. But in my case, I want to, none of the rest of that should know that this is Metal. So I just inherit MTK view and hide all the details about Metal from the rest of the app. My public API is, I'm going to, please give me pixels, and I'll go ahead and display them. And I also have some display settings, and that's my public API. Now for my internals, that's another question. So that's a bunch of stuff there. We've got like the device, command queue library, texture cache, pipeline state, and then some buffers. Right. What is all this stuff? Do I really need all this to convert my YCBCR pixels? We do, but it's not that weird. The device, that's just your graphics card. So the Metal device is your graphics card on your phone or on your Mac. It's the same thing. The command queue, though. So remember, the GPU is a separate chip on your phone. It's not the same as your CPU, where your regular Swift code is running. So to get things over to the CPU, the 2 chips are gonna have to talk to each other, sort of like a computer network, but insanely much faster. And we need a queue onto which to push these commands so that they can be sent over. So that's our command queue, and we get explicit control over that in Metal. That's the whole point of Metal, to get explicit control over the GPU. In order to put these commands onto the queue, we've got this really nice render encoder, which is a class that, it's a really weird name, but what it does is, it looks like it takes drawing calls, like it looks like you're drawing when you call it, but what it actually does, it serializes your commands into data that can be put on the command queue. That's pretty awesome. Then the easy stuff, we got the library. It's like a library of shaders. Texture cache keeps you textures. Buffers, that's GPU memory that you allocate for anything that's not a texture, like geometry and matrices and stuff. And then finally, the pipeline state. You can think of it as sort of your AV capture session or AV audio session or something. It's an object that represents the state of the GPU. All right, so those are the things we're going to need. Let's set them up in code. Actual Swift code. Here we go. Device, command queue, library, and texture cache. We just do the default constructors. Nothing weird. Next up, so we're going to need some buffers for our vertices. So in this extremely simple app, we only have 4 vertices. That's the full geometry that will ever exist in this app. And I'm just going to create. So that's X, Y, U, and V. That's 4 floats, and we need 4 vertices. That's 16 floats. So I'll allocate a buffer for that. Then we'll need a transformation matrix, and I'll talk more about that soon. And we'll create a buffer that's also 16 floats for that as well. And that's it. And once we got this up and running, we're going to want to acquire that GPU. Get that GPU goodness. And to get that GPU, we're going to have to tell iOS how we want to set the GPU up so that it can configure it for us. So here in the pipeline descriptor, we tell it, hey, I want to use this vertex shader, I want to use this fragment shader, and I want the pixels to come out in this video format, and then go ahead and create it for me. And then you have a handle to the GPU, and you can really go crazy. You can actually start drawing. Can you believe it? We're going to draw pixels. Yeah! It's going to be fun. Okay, let's see. Where are we? Yeah. Yes. Okay, everything's peachy. We can start drawing now. We're going to use DrawRect. You know DrawRect. Use DrawRect all the time. This is a weird DrawRect. You do metal in this DrawRect. So that's a nice thing with MTK view. You can even set it up to use set needs display. So you can do dirty rects and all that stuff, and it'll only render when it needs to, just like any UI view. But in the default configuration, it'll set up a timer for you and run at each screen update, 60 frames per second or 120 if you're doing one of these things. Yeah. So I get my DrawRect. First thing, I'm probably going to need those textures. We've got to get those source pixels that we want to draw out from the YCBCR texture. The first texture, I'm going to pick out the first plane, you know, the light values, all the gray from black to white. I'm going to put that in the first texture called LumaText. And then in the ChromaText, I'm going to get the other plane. That's going to get all the colors. So those are the 2 textures I got. And then later, I'm going to have to combine these somehow with magic. But before we get there, yeah, we're going to have to talk about matrices and math. Yes, here's the math. I'm sorry. It kills me, but it's also wonderful and amazing. Linear algebra is like the only math from school I can really respect and appreciate. It's beautiful. It's just beautiful. I'll run through the bare necessities to get through this. So, you know, we got a point. We talked a lot about points. Vertices exist at points in space. So when I want to move a point, I would use a transformation matrix. If when I want to rotate it, say I want to rotate this iPad around this corner like this, I create a rotation matrix. So I take my point, I multiply it with a matrix, and out comes a point. It's weird, but that's how matrices work. Cool. What more can I do with matrices? I can multiply matrices to make other matrices. So it's sort of like function composition. I got a rotation matrix and a scale matrix. You multiply them together, and suddenly you got a matrix that does both scaling and rotation, but in the opposite order, because math. Yeah, so it first scales and then it rotates, right to left. I don't know. Yeah, just do it that way. You can inverse matrices. So if you got a matrix that says go 100 pixels to the right, you can invert it and get one that says go 100 pixels to the left without even having to know what kind of matrix it is. That's kind of magical. So let's do something useful, like rotating around the origin. Everybody here knows that that's never useful for anything. It just rotates the thing off screen and you can see nothing. What you want to do is rotate about the middle. Yes, failed at that so many times. God. All right, so I'm going to have a translate to the middle of the rect matrix, and then a rotate matrix, and then a translate back matrix. And I can just multiply those together, and suddenly I have like a function that rotates about the middle. After like a decade of doing this, I've started to actually get it right nowadays with the order and everything, but yeah. Okay, that's all you need to know about matrices. They're nice, actually. We're going to have to talk about something else, math-like. We're going to have to talk about coordinate spaces, but you all already know about coordinate spaces. You use them all the time. Like the white dot right there, let's say that's parented to the purple square. That's a UI view. Then it's got a position of 50, x is 50 and y is 100. And if you convert point to view to the yellow box, now you get x is 150 and y is 200. So yeah, you've probably had to do that at some point. That's coordinate spaces. And it's super awesome because that means you don't have to reason about positions in a global coordinate space at all times. You can just position stuff relative to other stuff. Yeah, so it turns out game developers like that stuff too. They like their coordinate spaces. So what are the spaces we need to know about here? Sorry about the order in this slide. Don't read it top to bottom. So let's see. Okay, well, maybe top to bottom. Model space, that's the position of stuff in the subview. So if, let's say this is my model. I've created a 3D model for my iPad. And I have vertices in this iPad. Let's say these are 4 vertices. I don't need to give these coordinates in the space of the room. I can say it from the origin of the iPad. This vertex is 1 away in x, and this is 2 away in y. And I can have the coordinates in the space of the iPad itself. So that's model space. Then we have world space, and those are the global coordinates. Those are coordinates that are valid for the entire scene. So to go from world space to model space, you would multiply all the coordinates in the model with the model matrix. And that matrix will represent position and rotation and everything of the thing. So as I move it around, I can get exact world coordinates for everything on my iPad. So that's world space. Then camera space. Well, you can think of it as a camera. We have, we want to take a picture of the iPad in this room. And the picture is basically the contents of the screen. And so I'm looking at it from this direction. And I actually want just 2D coordinates for this thing. And so what I can do is I have a matrix that represents where my camera is, and then another matrix that represents flatten all that to 2D coordinates in my picture. And that's sort of the camera transform. So if I just multiply the vertex position by the model transform, by the camera transform, I get like a pixel location on screen with just the matrix. It's math. It's magic. Yeah, so that's great. We're going to have to do some of that. I'm not going to go through this. The reason I put all this stuff on this slide is because I spent an inordinate amount of time figuring out how to aspect fit a rotated rectangle inside another rotated rectangle, so you don't have to. I guess this stuff is on the internet, but I didn't fit anything that did, exactly the thing I wanted. So yeah, but the one thing I want to highlight here is, so when you got a metal view, it doesn't know what kind of coordinate space you want. So it says top left is 0, 0, bottom right is 1, 1. You figure it out. And if you got like different screen sizes and stuff, that coordinate space is terrible for doing aspect ratio fixes. Like you're going to have to I've been through this, you can tell. So what you want to do is you start out like the pretend camera matrix we do. We're not doing a real game here, but the camera, I pretend this is a camera matrix. It's just a scale factor. It scales x and y by the height and width of the view, so that 1 unit in your shader and like your graphics code is 1 point unit in UIKit, and it all comes together, and you can actually understand what the numbers mean. So that's nice. Finally, just one more slide of math, and you don't have to think about math anymore today. So my model matrix, the one I want to do, is I want to rotate. I want to maybe mirror the image if I'm looking at myself. I'm doing some sort of aspect, fit, and scale transform. So I just multiply all these together and I get a single matrix that does all that stuff for me. And then the final transform is that model transform and the camera transform, and it's a single matrix that I can input any vertex in and it'll tell me where it should be on the screen. Perfect. And I mem copy that over to the GPU and I'm good to go. Also mem copy over that quad, you know, the vertices from before. I copy that over to the GPU so it knows where to draw stuff. And now, okay, actually I lied before I said we're going to draw stuff. Now we're going to draw stuff. Yeah, now we're doing it. Okay, so we really do have all the data now. We're just going to mash it over to the GPU. So to mash stuff over to the GPU, we need a command buffer. It's sort of like a database transaction of here, please go ahead and make some stuff I can send to the GPU sort of thing. From that, I can create the rendering encoder that I talked about before, the one that looks like a graphics API, but it's actually a thing that serializes commands to send to the GPU. And on that thing, I can finally set my vertex buffer, my matrix buffer, my texture, my other texture, and I can tell it, please, Apple, draw me some primitives. Get me a triangle strip with 4 vertices on it, so I can get a square onto the screen. Please, and I end encoding, present it, and commit my transaction, and voila, I'm done writing code for the CPU. Still got to write code for the GPU, damn it. Yeah, okay, so let's talk about those shaders. Okay, yeah, we can do this. We're almost through it. So you remember this thing from before. So the rightmost red boxes, what are they actually? So, you know, the GPU creates what's basically 1,000,000 threads for you, like literally 1,000,000, like 1 thread per pixel. And it's got a bazillion cores, maybe 100 on your GPU, and it will run them concurrently, like actually concurrently. And then it runs your function once for every single pixel on the screen. And that all sounds complicated, but what it means is you can write just a really tiny function, because it really only needs to deal with one single thing, like, I'm going to draw a pixel, I can do it. And then that's pretty straightforward. All right, so yeah, so as I said before, the vertex shader is supposed to I get a vertex in, and then based on the other variables I got, it's going to figure out where it's going to go on the screen, and it's going to put it at the location where it is on the screen. Let's do that in the shader file. So this is yav.metal. It sort of looks like C++. I don't know, maybe. I'm going to start off by defining what a vertex is. You say, you already did that. And I say, I did that on the CPU. The GPU also needs to know what a vertex is, and the definition needs to match, of course. A packed float 2 is a weird type that's an array of 2 floats. That's GPU compatible somehow. That's going to be our incoming position, the exact vertex we defined in Swift. And the text coord is going to be the exact texture coordinate we did in Swift. So we know all that stuff already. But varyings, however, we've never seen that before. That's a neat thing. That's the output of the vertex shader. Yes, the vertex shader. So we're going to transform the position we get in, buy all this fancy matrix stuff, and we're going to get another position out. And that's going to be the position that the fragment shader is going to use later. And I'll explain how that works. And the same, but the texture coordinate, we don't do anything with that. We just forward that over. Finally, uniforms is a weird name for my GPU globals. That's the one variable we mash in the camera transform, that matrix we constructed. It's in camera transform. So we're going to use it. Here's our vertex shader. It returns varyings, as I said before. It's called model transform. That's just the name I named it. It takes a buffer of all the vertices, but we're only going to look at one vertex right now, the one in VID. And then it also takes the uniform, so we can use that fancy matrix from this function. So yeah, we pick out our vertex. We multiply the camera transform by the position, and that'll give us an out position, the position where it goes on the screen, with the rotations and mirrorings and aspect fitting, all that baked in. And voila, our vertex shader is done. we can go over to the fragment shader. You know what? This is like this line here, these 4 lines here at the bottom. That's the one thing we wanted to do this entire presentation. Now we get to do it. Jeez. So our fragment shader, it's called YOV2RGBA. It's going to take the varyings. Those are the ones we just created in our other shader. It's going to take the 2 textures, the lightness, the luma texture, and the UV, the chroma texture. And we're going to use a sampler. A sampler is a thingy that picks out a pixel from a texture and returns that single pixel value. So you can, like, if the destination doesn't have the same size as the source, we need to do filtering and stuff so that we get the exact right texture color. So we have Y and UV are just floats of stuff. And then we do math from Wikipedia that I don't understand, but basically we're creating an R value, a RGB, a red, a green, a blue, and alpha, and put that in out, which is an array of 4 floats. Yeah. Then we return that, and then that goes onto the screen, and we have displayed video on the screen. And does it work? Does all this toiling work? Yes, it works. How am I on time? Do you want to see a demo, or are you super tired? What? We're not very good on time. Okay, I will not do a demo. It's just a camera stream. Okay. All right then. Well, I thought you'd all be like dying right now because it's the last presentation and I'm talking math for like 40 minutes. Jeez, man. You're very patient. I'm impressed. Let's go to Xcode. Where did I put Xcode? Oh yeah. Here's Xcode. Where's my cursor? Here's my cursor. Where's my code? Oh yeah, so Metal supported. I'm going to pretend that Metal is not supported on this phone. That'll fall back to my CG graphics renderer. You know, the one from the first slide. You're going to want that code in here because Metal is not supported in the simulator, which is a huge bummer, which means that if you're doing regular apps and you want to use the simulator, you're going to have to write fallback code too. Yeah. But Metal is supported on Mac as well, so if you're doing like a game thing, you can just do a Mac app and an iOS app. But yeah, so here is the thing. That's you folks right there. Let's get the performance thingy. It's using a lot of CPU. You know, it's not great. So let's say we actually do have Metal. And compiling Swift takes a long time. This is our entire app. I didn't extract this into a project or anything, so it's compiling Swift. And you all know how fast compiling Swift is. Yeah. All right, let's see. Da-da-da. Okay. All right, we're getting some performance. Oh, here we are. Oh, yeah. And then, yeah, 16%. And, you know, aspect fit. Like, oh, yes. Like any rotation, it's just 10, 20%. That's some good code, if you ask me. Where's my cursor? All right. Well, thank you. So if you like learning about this kind of stuff, we'd love another iOS developer. I'm on Twitter. And all of this entire presentation is on GitHub. Yes, and I'm here, and I'm on Twitter. You can ask me stuff. Yeah, thank you.
Oh, I had a mic in my back pocket. Thank you very much, Nevyn. So that concludes the official program for the evening. I've been told that we can stay around until 9 p.m., but at 9 p.m. we need to be out of the building. Otherwise, some security guards will believe we're terrorists or something. So please make sure to be out by 9. And thank you very much for coming tonight. Thanks to all the speakers. Thanks to Sveriges Radio for hosting us. I hope to see you at more events. We have the DubDub DC. So who is going for DubDub? Quite a lot of people. Wow, I'm impressed. So everybody who's going to DubDub, there is a DubDub DC channel in Slack if you want to coordinate with fellow members and maybe meet up. And for everybody else who didn't get a ticket for DubDub, we're hosting a meetup on Monday to watch the keynote. Was that a question? No, awesome. See you on Monday. All right. Thanks, everybody, for tonight. Sit your butt.